pause, which is a whole. Said that a million times right now. 4 squared, 16, half of that is 8. 2 squared is 4. When you're dealing with pies, they're like variables. So the answer is 4 pi centimeters squared. And then you can go to your calculator and type the pi button. I got no time. All right. And I throw this one in there because, hey, we did this, last semester. I don't care. You're going on to Math 3 next year, potentially. So you might need to know this when you walk into that class. All right. So this is a 30, 60, 90. Interesting. The side opposite 90 is 16. So what's the side opposite 30? And those that can remember that will probably do quite well in Math 2. And it is half of that because remember, this is x, 2x, and then x times the square root of 3. I let that for dramatic pause to let somebody maybe answer that. All right, so the reason we need that, this is area of the shaded region, circle minus triangle. All right, and again, even the triangle formula, believe it or not, is on your Park exam formula sheet. So good for you. All right, this is a diameter. So the radius is 8. So I don't want to confuse that with that 8, but I need the radius of the circle. And then for the triangle, why did I need these sides? This is a right triangle. So this represents the base and the heights, whatever way you want to look at it. Area of a triangle is half base times height. All right? So 8 squared, 64 pi. Believe it or not, and you're going to kind of like this, the exact answer is exactly what I'm going to write right here. 8 times 8 is 64. Half of 64 is 32 root 3. So that's how you deal with numbers outside of the radical. You just multiply them and then you leave the radical alone like a variable. cm squared. Then you can go to your calculator and type this to get the decimals. I'm not going to do that. I think at this point, through all your practice all year long and hard work, you should be able to know how to do that. All right, probably going to discombobulate you here. I forgot to do 5 and 6, 5A, then you do B. And then, but you know what? That's the way the final works. You may have to jumble around and know these concepts randomly, not in any particular order. So for the drawing below, which looks very similar to a drawing we already did, see, I gave you different information though. JP is 6 inches. So that is a radius. But then here's the other thing. The question is different. Find the length of arc LM. Well, again, arc length is measure of central angle divided by 360 times circumference. Okay, where is LM? Oh, it's right here. So we got to do some math because I don't have this arc measure, and well, good thing it's a math class, right? And then we don't have this angle measure right here. So how do I find this angle measure? This is a diameter, and a diameter cuts a circle in half. Half of a circle is 180 degrees. So 180 minus, I'm kind of doing this for myself because I don't want to make any mistakes. So what's left over is 25 degrees in this little sliver, which means this is 25 degrees. Central angles equal the arcs that they cut. So arc measure is 25 degrees. Arc length is 25 divided by 360 times circumference. Now the radius of this is 6. Circumference is 2 pi r. So you're ready to go on this one. All right, and then you might want to go to your calculator and then go ahead. Well, most of the problem was not getting this step. Sometimes we did have issues from here on out. So let's just go ahead and do it. So 25 divided by 360, enter. This is always what I do. 2 times 6 is 12, times 12. And then you could even math frac that. And I know I'm going to get it. Well, there you go. It's 5/6 pi. And then we have to put this in inches. So again, I flipped the tables on you here, went back to length instead of area. So you got to be able to do that, and that's just fine. And then just go to your calculator and multiply that by pi. Times, I guess I didn't hit the times button, times the answer that we got there. 2.6. 2.6 inches. You have to understand that these are equal. This is just exact. That means leave pi like it's a variable. This is approximate. And you saw me do what I need to do to get both those answers. All right, so you do B, of course, and then I'm going to do 6, and you do 7, and then we'll get the volume after this. You got to be careful. This looks like area of a shaded region. Read, determine the perimeter of the shaded region. Perimeter is what is the distance if I walked here to here, then here to here, then here to here. Well, first of all radii in a circle are congruent. So that's 30 mm's. This is just an arc measure. So first of all, the perimeter is the arc length plus 30, which I just identified. That would be how much I have to walk around. So the only thing you have to do is find the arc length. 60 over 360 times 2 pi r. All right. Now I'm just going to go to my calculator for speed. All right. It's 60 divided by 360. If it makes you feel better, press enter. Times 2 times 30. And I'm leaving pi alone. Well, that's a nice number. So it's 10. I never touched the pi button. So it's 10 pi plus 60. That would be the exact millimeters. Millimeters because this is perimeter, which relates to circumference or arc length. All right, so 60 plus 10 pi, boom shakalaka, you get 91.4 millimeters. Exact, nope, I'm sorry, approximate, exact. Know the difference. Okay, don't forget you have to do 15. Don't get dizzy here, but I'm not gonna do anything. You gotta be able to figure that one out. It's pretty self-explanatory. Find the area of the shaded region, which is all the non-circle parts within that square. All right, so now we have to do this, which I have to jump back to the note sheet. Remember, this represents what we should be writing in our notes. I'm not printing that for you. Okay, or you should be able to scratch this on your own piece of paper and make your own little notes, and that's part of note taking and actually, getting your mind to remember stuff. The action of actually writing this helpful. All right, I'm just going to give you a little spiel about creating 3D figures. I'm just going to refer to old notes and give you the whole idea of what we did there, and you feel free to do with it what you want, and then we'll go on to finding volume. Making 3 dimensions from 2. All right. Remember we did this? I actually sat like a silly person in the middle of the room and I spun a pencil with a piece of paper on it. Spun it and I asked you, what kind of image does that make? And the answer was, it makes this, believe it or not, a cylinder if you spin a pencil like that. So I'm not going to do too much longer on this. You can make a 3-dimensional from a 2-dimensional object by rotating. All right. You can rotate this. If you rotate this with a piece of paper on my pencil, you get a sphere. All right, so hopefully you remember that. We did that. I was up in the front of the room. We were doing all that. Rotate this little triangle in here, and you actually, this is close, but it's actually a cone if you really think about it. So long story short, you can rotate in order to get a 3-dimensional solid. Another thing you could do is translate. All I had you do in class, if you remember, is take a triangle that is equal and put it anywhere on this isometric paper. So unfortunately, I'm in a program that I can't write on, but 3 dots, 3 dots, 3 dots. I go here, 3 dots, 3 dots, 3 dots, and then I connect those two triangles. So the triangles are the bases, and the triangle, and then you end up creating a 3-dimensional, which I actually called a prism, triangular prism. So you can translate. And then the last thing you can do is, well, this is another way of translating. So we translate 3-dimensionally. That's what we get when we do that. And then we focus on the names here. This is a triangular prism. This is what could be a square prism because it looks like we have squares here. Up at the top, you might say rectangular if you're not sure of yourself. These are called cylinders, you know that. And then here we got pyramids and cones. This is actually a pentagonal pyramid because it's named by the base. So all those things. All right. Then the last thing we asked you to stack, and then this is when you guys got all goofy about why would I want a square or make a square or a triangular pancake, if you remember, whatever. But if you stack pancakes on top of each other, you're going to get a cylinder. Okay, if you stack similar pancakes on top, meaning they get smaller and smaller until you get like a dot pancake, then what is that? All right, well, in a circular situation, that would be the cone. If you stacked pancakes just equal size on top of each other, you'd have a rectangular prism. Stack similar ones, then what do you got? All right, I think as the pancakes get smaller and smaller as you stack them, this is what we really did well with. And then this last one, if you there's the triangular pancakes. If you stack those on top of each other, same size, you would get a triangular prism. If you make them similar, meaning the pancakes get smaller and smaller until you get like a little dot at the end, that would be a triangular pyramid. Okay, so I just practiced all those names. So the reason we need to do that is